reactions. So we've learned how to write chemical reactions. We learned how to balance chemical reactions. And the last part is talking about these types of chemical reactions. So what we're going to do is we're going to classify reactions. We're going to categorize them. Because really, I mean, there are millions, and to tell you the truth, that's even too small of a word. There are trillions and trillions and trillions of possible reactions that can occur out there. So if you're going to want to study chemical reactions, we just can't study every single one of them. But we could categorize them so that we know what sort of hole they would fit into, what category would they fit into. So the first type of chemical reaction is called a synthesis reaction. So we have two or more substances combining to form one new substance. So for instance, if you have two reactants, like we have here, A and B combine together to form a new product, AB. So every time we have a synthesis reaction, synthesis means to combine together. Every time we have a synthesis reaction, we're taking two or more reactants, and we're always making just one product. So how do you know when you're looking at a synthesis reaction? Well, it's the only type of reaction that ends with one product. Okay? So here's a good example of that. 2K, so K is potassium, right? So 2 potassium plus Cl2, so that's chlorine gas, makes 2 KCl, right? So 2K plus Cl2 yields 2 KCl. And since I'm taking the K and the Cl's and putting them together to form one new product, I know that's a synthesis reaction. The second type of reaction is just the opposite. It's called decomposition reaction. So in decomposition, now we have just one reactant, and it's being broken down into two or more products. So it looks just like the synthesis reaction in reverse, right? So this is really easy then to identify also, because it's the only type of reaction that has one reactant to it. So one reactant is always breaking down into two or more products. So again, here's a good example of this. If we take some calcium carbonate and we heat it up, calcium carbonate will break down into calcium oxide, CaO, and carbon dioxide, CO2. Right? So I know this is a decomposition because I can tell that there's only one reactant, but there are two products. Right? So this is a breakdown, a decomposition. The third type of reaction is called a single replacement reaction. Single replacement reactions are where atoms of one element replace atoms of a second element that are in a compound. Okay? So you have a single element, and then you have a compound made up of two elements, and the single element is going to replace one of the elements in the compound. So for example, here's my compound, AB. Here's my single element. So the single element here can go in and replace one of those two. And then it takes that place, and the other element gets kicked out. So in this case, the C element here kicks the A element out, and now C goes with B, and A is now by itself. Okay, so single replacement, a single element replaces one of the elements in a compound. Again, good example of this. If you take some magnesium, some solid magnesium, and you put it in a solution, so AQ means aqueous solution. So if you put it in a solution of zinc nitrate, the magnesium will replace the zinc in the solution. So magnesium will go with the nitrate, and now the zinc gets kicked out. Right? So there's my replacement, my single replacement. And I can see that on the other side because now magnesium's with the nitrate, and now zinc is by itself. So again, most of these are pretty easy to spot, and that's going to be your job is to be able to look at a chemical reaction and state which of these 5 does it fall within. The 4th type is called a double replacement reaction. So a double replacement reaction now means that we have 2 compounds. Both the compounds are ionic, so they're made up of ions, and the ions switch partners. So here's our example. The first compound we have has A and B. The second compound has C and D. And now they're going to switch partners, right? It's kind of like a really bad prom. So A and B go to the prom together. C and D go to the prom together. At the end of the night, A goes home with D and C goes home with B, right? Because they didn't obviously like their dates, so they went home with each other's dates. So that's kind of what's happening in a double replacement reaction. So once again, I see that K and CO3 are together here, right? So K2CO3. And then I see that the BAs and CLs are together in this compound. So I have Ks and CO3s and BAs and CLs. And now look what happens. Now the K goes with the CLs, and now the BA goes with the CO3s. So there was a double switch here. That's why we call it a double replacement reaction. And then finally, we get to the one that almost everybody knows already. These are called combustion reactions. Combustion is just another word for burning. Anytime something's on fire, it is reacting with oxygen, and it produces a lot of heat and light. That's what we call fire. Okay? So fire isn't the product. Fire is just a lot of energy that comes off of a reaction that is a combustion reaction. The key here is, how do you know it's combustion? It's because there's a reaction with oxygen. So if I were to take some magnesium, and we actually saw this a while back, right, when we were talking about different families on the periodic table, and I showed you magnesium, and I showed you that if you put magnesium in a flame, the magnesium will burn. And it got really, really bright, right? So you saw this. So the magnesium burns with the oxygen and forms magnesium oxide. What we don't have in this is all of the heat and light. There is fire, but since fire is not an actual substance, we don't put it in our chemical equation. But we know this is a combustion, not because fire is listed, because fire is not listed here, even though it's there. It's because there's a reaction with oxygen. Anytime there's a reaction with oxygen, then we call that a combustion reaction. Now, the most common type of combustion reaction that you guys are going to ever see in here is going to be a combustion of a hydrocarbon. So you notice down here in this example, this is taking natural gas, which is also known as methane, CH4. And methane is going to react with oxygen to produce this blue flame. This is what we would see on like a Bunsen burner. This is also the kind of flame that you would see like on your stove. If you turn your stove on and you have a gas stove, this is the kind of gas that comes into your house. This is also the kind of gas that would be burned maybe if you have a gas water heater in your house, okay, or a gas furnace. So what happens to this hydrocarbon when it burns? It produces not only this flame, which isn't the substance, okay, but it produces the products carbon dioxide, which is a gas you can't see, and it produces water vapor, which again is a gas you can't see. So a lot of people think that the fire is the product of a combustion reaction, but it's not. It's these oxides that form. Like when magnesium is burned, magnesium oxide is the product. Flame is just the energy that comes off of it. Okay? So you've got these 5 types of reactions: synthesis, decomposition, single replacement, double replacement, and combustion reactions. Your goal is to be able to look at a chemical equation that's given to you and determine which of those 5 types it falls under.